Okay, I'm gonna do the video discussion post this week because I want to lose a low score on one of my quizzes. Yeah, couldn't pass that up. Alright, so since there wasn't a discussion post required this week, I went ahead and made my own up, chapter 16, and I chose to discuss the three major types of galaxies because I think that's just so cool. I mean, I never knew that there were different types of galaxies. I guess I just always assumed Milky Way, and there you go. You know, knew the universe was massive, but didn't know it was that. Wow. Yeah. So, sorry, I hate public speaking. I'm terrible at it. Alright, spiral galaxies is the first one, and that starts on page 405. We kind of get a short description of the three different types of categories there on page 405, and then it goes a little more in depth. Spiral galaxies, of course, are Milky Way, and we learned last week that they have a disk, and it's, I would say thin, but it's really not that thin. I mean, 1,000 light years. Wow. Sorry, I say that too much. And then, of course, the bulge in the center is more yellowish. It's brighter. And then the halo. And page, I have a picture here. You probably won't be able to see it very well. Page 407, I took it out of my book. Figure 16.3 is a picture of the Sombrero Galaxy. And the halo on this one, I chose this picture because it's just beautiful. I mean, sorry, can't see. There you go. You probably can't see the glare from my window. I do apologize. Alright, so we know that from the book, we know that they are filled with cool gas and dust, but interspersed with hotter ionized gas and have spiral arms. We also know that the disk stars and the halo stars orbit differently because we learned that the disk stars are more, they behave better. They're more in a normal pattern, if you can call it normal, and then because of course that's where we are, is in the disk. And then the halo stars are kind of all over the place, up and down, going in different directions. Anyway, that's what the spiral galaxies are. Sorry, I write better than I talk, apparently. Okay, the second type are the elliptical galaxies, and they are redder or more yellowish. They are rounder and they are elongated, and the book says like a football. And unlike the spiral galaxies, they have less cool gas and dust. And sorry, I'm reading from my computer. I had to type it out or I'd lose my place. And it says that that's probably why, or at least I'm assuming that's why they only have a halo and not a disk. And picture, in figure 16.5 on page 407, has a picture of a yellowish one. Sorry if you can see that. Not so well. There you go. Which is really cool. I mean, it just looks like a thing of yellow gas. But there are different sizes. So there's the rare giant elliptical galaxy that is among the most massive galaxies in the universe. I'd like to know how they know they're rare. I didn't see where I read that. But page 407 says that elliptical galaxies, therefore, and this is a direct quote, look red or yellow in color because they lack the hot young blue stars found in the disks of the spiral galaxies. However, large elliptical galaxies sometimes contain substantial amounts of very hot gas that emits X-rays. And sorry, Emma's a whiner. So I'm wondering if those hot gas that emit the X-rays are the reason why we know that they're rare. I mean, are we just not seeing them? If the universe is so massive, how do we know that they're rare? What if way out there are more? I would just like to know, you know, how we know that. That's fascinating to me. Okay, there are also the smaller ones, and they are dimmer. And page 408 says that astronomers have assigned them a special subtype called the dwarf spheroidal galaxies, which is kind of cool, but a mouthful. Okay, the third type of galaxies are the irregular galaxies, and these are anything that doesn't fit into the first two categories. And we learned about these if we're doing in the lab, and the first part, which is really cool, they're the large and the small Magellanic clouds. and these are moving towards us while some of the other ones are moving away, which is really way cool. So those would fit into this irregular category. Also, they appear to be in disarray, so not like our spiral or the other, and I didn't take out a picture of these ones. Oh yes, I did. Page 408 again, figure 16-6, right here. Sorry, I don't know if you can see that or not. But that is the Large Magellanic Cloud, and it is about 30 light years across. I mean, that's really, yeah, pretty much says it all. It says that they can be large or small, and page 408, and here's another direct quote out of the book, says that telescopic observations probing deeper into the universe show that irregular shapes are more common among the distant galaxies. So that's pretty cool too. Anyway, I'm sorry for all the ums and all that. I get really nervous. But that's all I had, and I would love any input you guys have on this. Thanks.